Hello everyone, I'm Shuang Zhai from Shanghai REFIRE Technology. The title of my report today is Development of Fuel Cell System based on Big Data Platform and AI Technology. The report is divided into 6 parts. The first part is the company and the product introduction. The second part is the construction and application of Big Data Platform. Then I will give 2 specific examples to show how to use AI technology to help product development. Finally, I will look forward to and summarize the work. I will introduce the first part now. Headquartered in Shanghai, REFIRE is the world's leading deployer of commercial hydrogen fuel cell technologies. Our vision is creating a sustainable energy future with hydrogen and fuel cell technology. Adhering to this vision, we are already helping to bring hydrogen-powered mobility to fruition. At present, there are 31 laboratories in the R&D center having the capacity of design, testing, prototyping, application engineering, and integration fuel cell systems. At Earthstar works in Changshu, we explore a new fuel cell manufacturing system. At present, the company has 2 product series, Kevin and Prisma. Kevin series is the first generation products with power coverage from 30 to 56 kilowatts, and Prisma is the second generation products with power coverage from 60 to 130 kilowatts. Kevin series is a sub-module design which is divided into stack module, air compressor module, DC module. Through the new mechanical architecture design and the component design of parts, Prisma series products have broken through the cool technology such as mounting design of air compressor, is soliciting direct connection between stack and DC-DC. A functional integration between the end plate of the stack and the cool components complete the integrated design of fuel cell power system and improve the ease of system layout and electrical safety. Up to now, our fuel cell in operation China has covered many regions, covering 6 provinces and 13 cities. We have already developed overseas markets, and our products have been applied to the United States, Japan, Germany, and Malaysia as well. Here are some typical cases. In Shanghai, more than 1,000 fuel cell vehicles have been put into operation in the Yangtze River Delta. It's the world's first commercial operation project of fuel cell logistical vehicles. It has been used by more than 20 domestic commercial enterprises for logistical distribution in Shanghai and surrounding cities, and has experienced the test of typical harsh working conditions of free gate transportation. In the Pearl River Delta region, more than 1,200 fuel cell vehicles have been put into operation with buses and logistical vehicles equipment with REFIRE fuel cell system. By the end of November 2020, they have driven more than 10 million kilometers and achieved a better customer experience than traditional buses and logistical vehicles. In addition, in Guangzhou, we also support the customer to complete various fuel cell and municipal sanitation vehicles, becoming the first batch of fuel cell sanitation vehicles in China to enter the test and use stage. In Asia, the 7.5-ton fuel cell logistical vehicle recuperated with Fuso was unveiled for the first time at the 46th Tokyo Auto Show in 2019. In 2019, the first batch of 9-meter fuel cell buses were delivered to Malaysia for local operation. In Europe, we cooperate with Germans ECAP to promote the multi-scenario application of hydrogen energy. In the United States, the fuel cell heavy truck we cooperate with FAW was put into test and demonstration in Los Angeles Long Beach Port. I will play a video to let you know how a more intuitive understanding of our company and working environment. Now the second part, construction and application of big data platform. Our big data platform is divided into data management layer and business application layer. In the data management layer, firstly, the original data warehouse is established by collecting development data, product line data, and vehicle operation data. Then we will establish an available data warehouse through data filtering. After data mining, it becomes high-value data, so as to support the iterative development of products, quality tracing ability in the whole cycle life, after-sale maintenance, and the use of future services. Today, we will focus on the vehicle operation data as an example to introduce our work. In the process of vehicle operation, we will collect more than 800 kinds of signals, such as environmental, powertrain, and the fueling information, and then optimize the fuel economy and durability of the vehicle through data filtering, visualization, and data mining, and improve the reliability of products through fault diagnosis. This page is the interface of our remote data monitoring platform. You can see our online vehicles every day, having consumption information, alarm information, vehicle distribution, and statistics, our operation and fueling information. In the after-sale application, we can carry out our fault diagnosis of core components of fuel cell through background algorithm design, such as operation information and statistics of air compressor. Through probability statistics and mechanisms analysis, we can also set the liquid states through our stack and give earlier warning in advance. We can also make a real-time statistics and alarm of hydrogen leak information. In addition, our data platform can support R&D engineer to provide online remote assistance to after-sale engineer. We also realize the data interacting based on cloud data. We can refresh the software of the system so as to timely solve the system problem or better adapt it to the changes of the environment and maintain the optimal states of the vehicle and the system. Now the third part, fuel cell system fault diagnosis and early warning based on big data. In the active operation of fuel cell vehicle, there are many problems such as single vehicle information alert and many fuel cell fault dimensions, which lead to high difficulty of fault diagnosis. Therefore, it is necessary to carry out fault diagnosis through cloud platform cross-spatial scale comparison, principal component analysis, and other methods of fault feature vector. Our fault diagnosis process is shown in the left feature. First, based on the data of online parts, a static SVM model established through processing. For the new sample sites, we process and then perform k-means clustering analysis and then run the adapt SVM model to analyze and diagnose the real-time samples. Thus, a closed-loop online fault diagnosis method is formed. In order to verify our method, we carry out our simulation verification. Firstly, PCA pre-searching is carried out based on the existing voltage data in the library to obtain the dimensional reduced data set. And then the collect samples are labeled by k-means cluster. the accuracy is about 70%. Because all the newly collected samples are much less than the initial training samples and are only used to improve the original cluster rather than retraining, the error rate will not affect the final diagnosis accuracy of the model. Compared with the static cluster, the boundary of the dynamic cluster change obviously. But when the collect symbol X2 introduce number of support vector or as well model increase and the position and the shape of the boundary change, so as to realize the dynamic update. Based on this, by identifying the new test subsample set X3, the diagnosis accuracy can improve from 98% to 99%, so as to realize adaptive adjust of diagnosis model and improve the fault diagnosis accuracy. In practice or engineering application, we conduct the principal component analysis of main fault model based on cloud platform, cross-species real data, and realize multi-vehicle interactive fault diagnosis and fault earlier warning through GG cluster method. In the past 3 years, the longest vehicle operate has exceeded 4,500 hours, breaking through the active operation mileage of 20,000 kilometers for the first time. Based on the working conditions, the actual polling life can reach more than 27,000 hours. According to the operating status and comparison of cloud platform data, the mileage between failures has been increased by more than 3 times. At the end of 2021 July, our fuel cell system has running more than 60 million kilometers in total, and the fault-free internal mileage health system has been increased to 50,000 kilometers, improve the reliability of products year by year. The fourth path is development of fuel cell economy improved strategy based on big data. At present, due to limitation on the infrastructure such as hydrogen fueling station, fuel cell vehicles are more than in the form of fixed routes, which reduced the difficulty of fuel cell economy optimization to a certain extent. However, in order to actual the correct data working condition, key means and other methods used to need to be used for clustering analysis. We have completed the local optimal energy management strategy before. Now we are trying to carry out the global management optimization. According to the SOC starting point and end point, we can find the path of the optimal SOC to achieve the global optimization of hydrogen consumption. Our simulation results show that for the working condition of 31-ton dump truck compared with the local optimized management methods, the hydrogen consumption can be reduced by more than 1% through global optimization. Now, next, the real vehicle will be verified. Next, we hope to use the long-time scale real vehicle data for the cloud platform to establish the life characterizing quantity and model-based the data-driven methods, and use the dynamic program to realize online optimized predictive control of operating conditions so as to optimize the life of fuel cell vehicle. Our general idea is shown in this figure. The following is a summary. We have built a closed-loop data platform for the whole life cycle, from R&D, production to application. We can carry out research work such as fault diagnosis, life optimization, and fuel economy improvement based on this data platform. We are willing to work with interested research institutions or university to conduct AI technology research based on big data platform, improve product quality, and give full play to the value of data. Thank you.